The lesson topic for this video is applications of quadratics, and this is part 2. All right, so the first example in front of you says you have a rectangular patio which measures 15 by 23 feet. Now if you look at the diagram here, we see the 15 and the 23 right here. So this is the current rectangular patio. You wish to double the area of your patio by adding the same amount of new space to the width and the length. Find out how many feet of concrete you must add. So that's this linear amount of feet. So we're looking for the value of x. All right, so thinking through this problem might take you a little bit of time, and what might be good for you is to pause the video and see if you can try to write the equation that you would need to use to solve this, and then restart it to see how you did on that. But one thing you do have to pay attention to is this idea of doubling the area. So we'll get to that in a moment. So first, what you probably maybe thought about needing to do is finding the current area of your patio. Again, this is the current area of the patio right here. And we know the area of the current patio is base times height for rectangles, right? So the area is 15 times 23, or in other words, the area is currently 345 square feet. All right, that's the current area of the blue rectangle. Now, here's the thing, okay? We want to double the area. Well, that means all we need to do here to double the area is to take the current area, which is 345, and multiply that by 2, right? And when we do that, we're going to get 690 for our new square footage of our new patio. That's our new area. All right, so then how do we find the length right here of x and x right here to make that new area work out? Well, this x value right here is a portion of this entire width right here. So if we think about what this entire width would be right here, or the base, if you want to call it that, well, we know it's the value of x here plus 15 more feet. So 15 added on to that x, we have x plus 15 for that length there. Well, how about this here? Well, that's our current 23 plus additional x feet, so we can say that's x plus 23. And if you had written 23 plus x, that would work fine as well. So these are the new dimensions of the patio, the new patio, x plus 15 by x plus 23. But again, we want to find out that x value. So at this point, hopefully you're noticing that we can use our new area with our new dimensions and find out what that value of x would be. So the area of our new patio is base times height. The area is going to be 690 square feet. The base of the rectangle, the new rectangle, is x plus 15, and the height of the new rectangle is x plus 23. Now, just like in part 1 of this lesson, we are going to put this into our calculator for y1, and we're going to put this in our calculator for y2, and we're going to find out where they intersect. And notice there will be 2 different locations, and we're going to find out if both of them work or if there's just one solution to this quadratic situation. So go ahead, grab your graphing calculator, put this in for y1, put this in for y2, change your window. Remember what we talked about in the first lesson is change your window so that your y1 value is on the screen. So we have to move all the way to where we can see 690 on that. All right, go ahead, give it a try and see if you can find the new value of x here to make the new patio. Again, if you change that y1 window, you're going to end up seeing a parabola. This is like 690 up here. You're going to see a parabola coming around through like so, and you're going to end up getting this value here for your intersection, which is 7.571, and that's in feet. So that's how much we would add here and here to get our new base and our new height. That would give us 690 square feet, because that is doubling the current size of the patio. Again, there's one more value way over here somewhere. It is actually at about negative 45 for the x value, and of course we can't add a negative 45 units to a patio, so that negative value will not work. We just have our one answer. All right, let's try one more. It says a carpeted area is 6 feet longer than it is wide. The total area of the carpet being used is 106 square feet. What are the dimensions of the carpeted area? You guys, make sure to draw yourself a picture. If you don't draw a picture, you're not really working very hard on these quadratic geometry connections. So the carpeted area is 6 feet longer than it is wide. Well, how wide is it? We don't know. What do we use when we don't know? Well, we use x. So then if the other part is 6 feet longer than that, that means it's whatever the x value is plus 6 more feet. So this will be x plus 6. Notice it's not 6 times x, because that would be 6 times longer, not 6 feet longer. So now we have our dimensions. We have x and x plus 6 for our area of our carpeted area, and this is 106 square feet as it tells us in the directions. So this one's a little bit more straightforward. Area equals base times height. Our area is 106. Our base is x plus 6, and our height is x. Once again, we're going to put this in for y1. We're going to put this in for y2, and we are going to find our value for x that will make this rectangle carpeted area work out. Go ahead and try it on your calculator and check to see if your answer is right. Okay, again, there are 2 different locations that your parabola will cross your line at 106 if you change your window. The first one's at negative 13 point something. We can't have a negative 13 for a length in our picture. And the second answer is 7.724. So we know that the dimensions, we should answer the final question, the dimensions are 7.724 by 13.724. And we get that second value right here because we add 6 to what x is. So if I just add 6 to the 7 here, I get 13. So here are the dimensions. You can check to make sure that they multiply together to give you that 106, and one is 6 feet longer than the other.